All right, how's it going? This talk is called The Last Mile for ZK because as you guys know, the last mile problem is always about the hardest part of getting things to consumers or to customers or to users, to developers. So the point of this talk is one, to give a quick update on one, what have we been doing, and two, what are we working on, and three, where are we going? So let's jump into it. To start, for those who are new to Aleo, I want to just give a quick overview on what Aleo is. Fundamentally, it's a platform that lets you write zero-knowledge applications. That's the idea. In order to make this happen, there's really three main parties in the ecosystem that we ourselves are trying to support and also build a community around, and that's developers, that's provers, and that's validators. The idea here is that developers, they run applications, they create applications, and they send requests. These requests go to provers. Provers execute these things. A user themselves or a developer themselves could be a prover as well. So it's worth pointing out that these parties may not be mutually exclusive. But the point is that provers execute applications and they execute them at scale. These things get executed into transactions that are broadcast onto a network where validators basically admit them via consensus and then sends the results back to the developers or the users. In terms of what we've been working on to make this thing happen, well, one of the things that we've been developing thus far has been, in terms of networking, there is a lot of communication overhead that goes into actually getting this type of richness of application state across all users. And so we have been building out, there's a paper called CADCAS, which is a protocol that is similar to Kademlia, whereby it allows you to, via a topology, discover other nodes and quickly, effectively propagate information to them with a high guarantee that it's widely distributed and widely disseminated amongst that network. This is something that we think is going to be absolutely necessary or critical in order to get data out there at scale with speed. Going into the ZK side of things, I think one of the things that's also worth bringing up is, so the proof system that we use is called Marlin. Marlin itself is a universal and updatable zero-knowledge proof system. It is similar to Groth in the sense that it uses R1CS as the expression or the underlying representation to write actual programs in. But with Marlin, we have done some fun work with it. Namely, one thing which you guys who are familiar with the Plum community familiar with is lookups. The idea that I can basically create these kind of custom constraints and look up specific values in order to use them in specific operations. So for example, if I want to create a hash function, or if I want to create thereby a Merkle tree that's far more efficient than what we're traditionally used to, that I can create this table, look up values from it, index it in, and then use them direct. This is something that we've been able to effectively build into the current Marlin schema, and it's something that we're very excited about using. We think that it's going to give us a very, very performant prover with that. The other aspect with respect to Marlin that's worth bringing up is this design actually allows us to do batch proving. So what do I mean by that? Well, normally when you want to execute a transaction, let's say it's a transfer, and you want to send to 5 different people. You might do 5 different transfers, right? So the cost is linear. You basically pay 5 times the execution time, right? With batch proving, the beauty of it is that you can actually effectively bring things down to close to just 1x. So if I want to send to 5 people, it's just slightly more than sending it to just one person. Ditto if you want to send to 10 or 20 or 30. It's a way to aggregate the actual computation and batch these executions together. And it's something that we're very excited about in terms of scaling up designs. Naturally, you can almost think about there's rollups out there, people love rollups, and this naturally gets you very efficient, very fast rollups. And so it's something that we're looking forward to using as part of the underlying compiler system that we have coming out in testnet3, which I will get to in a moment. Another thing that's worth bringing up is threshold signing. This is another cryptographic primitive that we've been working on, and as an update, we have been able to get out some new work in terms of Frost. We've tailored the design for our specific addressing scheme, and for the cryptographers in the room, the gist is that we needed to update the verifier challenge to include some additional group elements that pin it to the exact commit, or basically commit to the exact schema that we have with our private keys. But the high-level idea in terms of threshold signing, for those who are unfamiliar, is that say I want to move a transaction from A to B. Normally, what you do, you just sign it yourself, and then you move it on. But sometimes maybe that key is very sensitive, and you don't want it yourself. So what you do, you can share this out to a number of people, and this gives you a way to effectively allow a large group of people, some who you may trust, some who you may not trust, to basically create a transaction for you, and none of the parties in this particular model would learn the private key in doing this process. And it allows you to do a threshold of them so that this way, if some of them go offline by accident or intentionally, the protocol remains resilient. It's one of the things that I think has been, well, frankly, missing in a lot of L1s, but it's something that I think we're very excited about getting out there. All right, and then the last thing before I jump into the main plans is Coinbase puzzles. So for those who have been familiar with testnet3 on our front, we had this thing called proof of succinct work, POSW. And the idea with POSW is to say provers can basically solve this puzzle that allows you to generate a proof that is used for, well, one, minting new supply into the ecosystem, but then two, also for getting a incentive to actually develop faster and larger hardware. And I'm really excited to announce that we have a new design with the Coinbase puzzle, one that I think a ton of provers are going to love, which is that we've focused it down to its core, which is MSMs and FFTs. For those who are unfamiliar, MSMs are multiscalar multiplications. They're like multi-exponentiations, if you're familiar, where you have different group elements in the base, and you have different scalar elements in the exponent, and you're basically trying to efficiently compute like g to the x1, or g1 x1, g2 to the x2, g3 to the x3, dot, 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 and so on, and compute one value out of it. With FFTs, that's fast Fourier transforms. It's a signal processing algorithm that, in this case, allows us to do polynomial multiplication very efficiently. And with this new design, what we actually end up with are proofs that can be roughly 100 bytes in size and about a millisecond to check. And for a schema like this on chain to mint new supply, we think that this is going to be a huge win in terms of getting a fair distribution of tokens out there to provers who are in the ecosystem. A much more formal and well-documented write-up will be coming when this comes out. I know I'm running short on time, so let's jump right into the main thing, which is we're really excited to announce that testnet3 is going to be coming out. Testnet3 will be coming out in 3 phases. The first phase comes out August 1. And we will be bootstrapping a network with what we call Genesis beacons. These are going to be the nodes that basically set the Cannon chain in place. Anyone will be allowed to install SnarkOS in this case, run a node, and basically sync with the network. Developers from day one will be able to write programs, deploy them, and execute them on the network. And that's something that we're very excited about getting out there literally in, I think, 2 weeks. Yeah, 2 weeks, yikes. But on to phase 2, September 1, yay, more time. With phase 2, we are going to be releasing these Coinbase puzzles. So provers will be able to start producing proofs that are going to be checkpointed into blocks. Provers will be able to earn credits as part of doing that. And separately, we'll be kickstarting a bug bounty program for SnarkOS and SnarkVM. This will be open to the public. Anyone can participate. And we're very excited to try to find all the bugs. Like I keep catching bugs, so I look forward to people's submissions. I hope none for funds, but yes. Lastly, for the third phase, which I think is going to be the most exciting, is October 1, we will be opening up the network to anybody to validate. Any prover who has accumulated 1 million Aleo credits to start will be able to become a validator. Any other person, anyone else who has tokens, can delegate them to existing validators by bonding and also removing stake by unbonding on the network. The incentives in this design will be fully laid out in writing, but to give you the intuition for what we're doing here, the goal with Aleo's consensus mechanism is really to incentivize hardware acceleration for zero-knowledge proofs. That just does not exist in the ecosystem today. We think it's a vital part of bootstrapping ZKPs for this next decade. And for the people who make hardware today, one of the big challenges is that they just don't have the ability to actually incentivize themselves even to manufacture custom chips for it, because there's just not enough revenue streams for it. We want to use this as a bootstrapping mechanism that allows them to actually back themselves into dedicated hardware and go and basically incentivize them to go and execute proofs with this. Naturally, the puzzle we've designed here is also going to tailor for hardware that will speed up actual programs on the network. And so as a prover, you kind of have a free option of saying, if there are jobs to execute, I will execute normal execution requests from users. If there's no jobs in the moment and my machines are sitting idle, I can go and work on these puzzles in order to mint new supply into the ecosystem. And that's the high-level idea here. We think that with this design, First off, the reason why we need validators in this design is someone needs to keep the provers in check, because they won't be able to keep themselves in check. So with validators, the rationale is that honest validators who are staked will be the judges in this. They will enforce that the provers actually hit the targets that were required via consensus to be admitted, and that the correct amounts were issued to them via these issuance mechanisms. But yes, this is coming October 1. We're very excited about that, and I think that will be a huge part of what's to come. I think there's supposed to be one more slide, but maybe it got lost. Well, I guess the last slide was to say thank you, but also that we are doing a developer workshop tomorrow. The developer workshop, if you go to lu.ma, Luma, lu.ma/AleoEthCC, you can sign up on there. I think we're actually at waitlist, I think. But nonetheless, if you sign up, we can get you guys a response later today. Oh, and there are cards at the table there with a QR code? Okay, with information about it. And so if you guys are interested, feel free to hop over there and grab a link. Look forward to seeing you there. And that's my talk. Thank you very much.